Hi everyone, welcome to Sigma Maths. In this video we're going to be putting our new Advanced Trig formula into practice. In a previous video I went through how we arrive at each of these formula, and if you haven't had a look at that I suggest you go check it out. Not only is it good to know where your formula come from, but if you're aiming for a high grade, then you need to be prepared to prove these formula in the exam. Before we get started on the questions, I just wanted to remind you of the formula that we're looking at. We've got our area formula, half AB sine C. We've got our sine rule, which comes in two forms. The top one here, if you're looking to find a side, and the bottom one here, if you're looking to find an angle. And then we've got our cosine rule again, top one, if you're looking to find a side, and the bottom one, if you're looking to find an angle. Also, when you're doing the questions, remember that labelling is important, and that these lowercase a, uppercase a, these two things have to be opposite, okay? So each of your letters have to be opposite the same letter. Capitals for angles, lowercase for sides. Now every time a question comes up on the screen, you should pause the video, have a go at it yourself, and then play again and see how you did. Okay, so here's question 1. I'm going to start by labelling the angles and sides so that I can use my formulae. It doesn't matter how you label the angles and sides, as long as you stick to having the same letters opposite each other. So I've gone with A, B, C, like this. Okay, remember I said in the previous video, when we're trying to decide whether we want the sine rule or the cosine rule, we need to look at how many sides and how many angles we have altogether, including the thing that we want. Here we've got two angles, and including the x, two sides. Two angles, two sides is the sine rule. Okay, so we are trying to find a side, so we want to have our sides on top. So the working for this is going to look like x over sine, remember it's always the angle opposite, x over sine 42 equals 13 over sine 52. And then we can rearrange this, and I always like to write down my working of the rearranged formula rather than typing things in before and writing them down. So I don't want to write like a decimal value for this fraction down and then times by sine 42. There's a possibility there that you could write down a rounded value, then use your rounded value in a calculation, which would result in a rounding error in your answer. Okay, so we're going to stick this into our calculators, see what we get. Okay, so you should have got 11.0388, etc. It's always reasonable to give you answers to 3 significant figures if the question does not specify. So that would just be 11.0 or just 11. Don't forget to put your units in. There we go. Question 2. Again, I'm going to label my sides. Doesn't matter how. I'm just going to jump in with A, B, C, and then follow through with my A, B, C. Right, this time I have only one angle and 3 sides, including what I want. So this is going to be an example of the cosine rule. I'm looking to find a side, so I can use the original version where it starts with the a squared equals b squared, etc. So the setup is going to be x squared equals, and then I do the sum of the squares of the other two sides, so 9 squared plus 12 squared, and then it's always minus 2 times the two sides I just used, 2 times 9 times 12, times cos of the angle that sits between them, which will also be obviously the angle that sits opposite the side that I'm looking for, cos 104. Okay, again, we're going to stick this into our calculators, and then we're going to be very careful to remember to do the square root at the end. Okay, so before square rooting, we get 277.25 dot dot. I'm just going to put a dot 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 there. Keeping the answer in your calculator, if you then square root what you get, 16 point, and that will be 7 to 3 significant figures. 3 sig fig. Okay. Right, question 3. Label again. A, B, C. By the way, when you get confident with these formulae. You might feel that you don't need to label the sides anymore because you're used to how the formula works. That's absolutely fine. There's no marks for labeling your triangle. But while you're still learning and in the process of revising, then I suggest labeling just to make sure that you put things in the right place. Okay, so this time 3 sides, 1 angle. It is the cosine rule again, but this time we're trying to find the angle, so we're better off using the cos A equals b squared plus c squared minus a squared over 2bt formula. So that's going to look like cos x. So I do the 2 sides that are either side of my angle first, 11.7 squared plus 15.2 squared, and then I minus the side opposite my angle squared, 5.4 squared, all over 2 times 11.7 times 15.2. Okay, so I am going to write down what cos x equals before I then do inverse cos to get my answer. Okay, so that comes out as 0.9524, etc. And then inverse cos, and that gets us 17.7 degrees to 3 significant figures. Okay. All right, question 4. Now, if you're just about to pause, just hold on a second. I will warn you, you need to be very careful in this one. We are actually going to meet the ambiguous case of the sine rule in this question, so maybe just bear that in mind before you start. Okay, so let's proceed as we normally would. I'm going to label my sides. A, B, C. And I have 2 angles, including what I want, and 2 sides, so it is the sine rule. And we're going to see something interesting happen in this question. Okay, so if I was to just put this straight into the formula, I would get sine x, so I'm putting my sine on top because it's the angle that I'm after, over the opposite side, 11.4, equals sine of 36 over its opposite side, which is 9.3. Okay, putting that into my calculator, I'll be putting in sine 36 over 9.3 times 11.4, which that gives us 0.7205 ... And if I do inverse sine on that, I get 46.1 degrees to 3 significant figures. Now, if you're paying attention, you're going to notice that this is an acute angle, and if we look in the question, the angle that we're trying to find here, that is definitely not acute, that is obtuse. So something must be wrong, but we've applied the formula correctly. Everything here looks fine. So why are we not getting an obtuse angle? And this is where we meet, as I mentioned before, the ambiguous case. So having a triangle that has sides of 9.3 and 11.4 with an angle that is not the angle that sits between them basically leaves us with 2 possible triangles that we could be looking at. Let me show you what the other triangle could be. Okay, so if you see this dotted line that I've got here, this is where our x was before. Okay, so this part of the triangle here, that's the original triangle that we had. So now when we start with this 36-degree angle and we go along 11.4 centimeters, at that point we have a choice. We can either go back in on ourselves, 9.3 centimeters, to arrive at the triangle in the question, or we could go out a larger angle, 9.3 centimeters, and produce this bigger triangle, which still has the same 2 sides as the first triangle, the same angle, 36 degrees, but now x is a lot smaller, and this base, the AC base, if I label this in the same way, A, B, C, this base is a lot longer. Okay, so it's an ambiguous case because given the information, if we didn't have the diagram, if we just had the information of the 2 sides and the angle, we would not know which triangle we were supposed to be using. Now, when you put inverse sine into your calculators, you will always get the acute angle come out first. And if we just look at that on the sine graph, 46.1, so that's a little over halfway. So there's our 46.1. That lines up with the 0.72 that we got There you go. When we put in our what sine x was equal to. So what happens here on the sine graph then is if I carry on along at 0.72, I hit the sine curve again, and I come down and land in the obtuse section. So the 0 to 90 degrees part of the sine graph, that relates to all the acute answers. That's the one, they're the answers that your calculator will always give you. But then there's also an answer that sits in the 90 to 180 degree range. Okay, and this is where the ambiguous case originates from. It's because the sine graph has these two possible solutions. So how do we find this? Well, this is 46.1 degrees up from 0, which means that this value here must be 46.1 degrees down from 180. Which means we are working with here a value of 133.9 degrees. Okay, so here I would put or 133.9 degrees, and actually that's the one that we want for this question, because this value is acute and we want the obtuse answer. Okay, so this one here would have been our 46.1, which would have worked just fine, but we were interested in the 133.9. So two things will happen in a question that's about the ambiguous case of the sine rule. Either they will be very clear in the question whether they want the acute or the obtuse angle, in which case you will only give one answer, but you need to make sure you give the right one of these two answers. And the other option is that they will ask for two possible answers. So that kind of gives you a clue. It reminds you that there's two ways of getting to the answer. And remember, it will always be whatever value you get out of the calculator, and then 180 minus that value to find the second option. Okay, so question 5. Now, this is an example of the type of question I was just talking about, where it actually says in the question, find two possible values for something. So straight away that's given us a bit of a hint that maybe the sine rule is involved, and we're going to have to consider the ambiguous case. Now, this question hasn't given us a diagram, which is going to happen every now and again, so we're going to have to do our own. And I actually suggest that we draw two diagrams in this case so that we can see the two possible options that this information could give us. So make sure you have a go at this before I show you. Now, the first triangle that I came up with is this one. So I've got my base PR of 7 centimeters, then we've got an angle of 25, and then we've got our side QR of 4. Now I've gone with going along 7 centimeters to R, and then coming back on myself to draw the 4. The other option would have been to go off at a larger angle with the 4 centimeters. So this version here has given us the shorter possible PQ, and the other triangle would look more like this. So I've still got my base of 7 centimeters, I've still got my 25 degrees, but this time, like I said, I've gone off at a larger angle for the 4 centimeters, producing a longer PQ. Okay, now we need to think about how we're going to actually get to find the value of x. We've actually got two options here, because if we initially start with our count up how many sides and angles, then we would say, okay, we've got 3 sides, including the thing we don't know, and 1 angle. So we could use the cosine rule to do this. But bear in mind, because we're not trying to find the side opposite the angle, then we are going to have the unknown appearing in 2 places in our equation, and that is fine. It actually produces a quadratic, which we can solve no problem, and I will go through that working with you. But then there's also slightly more working involved, but maybe easier to follow, sine rule, using the sine rule to do this, which is basically where we find another angle in this triangle, which will allow us to know all 3 angles in this triangle, and then we can actually use the cosine rule with the angle opposite the side, which is just a little bit easier to use. We don't have to worry about any quadratic equations. So we'll go through both processes together now. So at the moment, my triangle is labelled with PQR. If you much prefer to work in ABC because it relates back to the formula, then of course you can change these. You could just replace the P with an A, Q with a B, and R with a C, for example, so you can still relate back to those formula that we've learnt. But hopefully, by the time you're doing slightly harder questions like this, you're kind of getting a bit more used to the formula, you know how they work, and you're able to put the numbers straight in. Now, if we have a look at this, if we try and use the sine rule to find out another angle, we've got 25 and 4 pair up together, and then because we know the 7, the angle we'd have to find is the one over here, Q. So I'm going to call that y so that I can link back to it in my question, in my working. And bear in mind, if we do find a second angle, then we will be able to work out the other angle in the triangle. And once we know that angle, we'll be able to work out x using the cosine rule. It'll be fairly straightforward. So let's write down our working for this. It'll be sine y, so sine rule with the angles on top over 7 equals sine 25 over 4. So this produces an answer of sine y, so we're going to multiply up by the 7. So we get sine y is 0.739, etc. So let's write down our y value from that. So what we get from that is 47. Now this isn't my final answer, so I don't want to round to 3 significant figures yet, but I will round, I'm going to go for 5 significant figures, and I can use my answer, so it'll be 47.696. I can carry this answer forward. Okay, now clearly this working does not fit with this triangle, obtuse angle, acute angle. So actually, if we come over to our other option, this would correspond to our 47.696 degrees for this triangle. What we want here is the alternative. So this is where we do 180 minus this answer. So for this triangle, we are going to use 132.303. So we're going to use 132.304 for the calculations to do with this first triangle. Okay, so now we know this angle, we can work out the angle opposite our x. So if we do 180 degrees minus 25 minus 132.304, we find that this angle is 22.696, and then we can use the cosine rule. So x squared equals 4 squared plus 7 squared minus 2 times 4 times 7 times cos of the 22.696, and then I'm going to jump straight to x equals, remembering to square root the number that I get on the right hand side. Okay, so the outcome after square rooting is 3.65. Okay, I'm going to stop there because I'm going to give my final answer to 3 significant figures. Sig fig. Okay, so let's do the same working for the other triangle. We're expecting to get a larger answer for x this time because this one's using the triangle that has a larger angle here. So we already worked out that y was 47.696, which means we just need to do 180 minus 25 minus the 47.696 to find out the angle that we will be using in the cosine rule. So this will be 107.304. So we go into the cosine rule again, x squared, so all the same working, minus 2 times 4 times 7 times cos, this time of 107.304, and from that we get a 9.04 if I give my answer to 3 significant figures. So it is larger as we expected, almost 3 times as large in fact. And there we have it, our 2 different answers. Now I did say that we could have used the cosine rule to do this process, so just take in how much working we've done there, the processes that we went through, and then here's the alternative way of approaching this. So let's get rid of all this working. Okay, so using the cosine rule then, if we labelled this with a and little a over here, and then it doesn't matter which way around these are, so I'm just going to do them this way, and we put these in, we would get 4 squared equals 7 squared plus x squared minus 2 times 7 times x times cos of 25. So do you see we get the x squared term, but we also have an x term here. So it's a little bit messier, to be a little bit more careful. Notice that it's a quadratic and then solve correctly. So I do think, although this is less working to write down, that the other method might be easier to follow for some. So as soon as we notice it's quadratic, we know that we need to get it into the form ax squared plus bx plus c equals 0. So we've got our x squared term, that's fine. Now I'm going to put minus 14 cos 25. Now that's going to be a decimal number that I don't want to have to write down. So I'm going to leave that there and put that straight into my calculator as and when I need to. And then here we've got 49 minus 16. So plus 33. Okay, so that's what it's going to look like when it's rearranged into the right form. Now here you can put this into the quadratic formulas, probably the easiest thing. So it's going to be minus b, so that's just 14 cos 25, plus or minus the square root of b squared, so 14 cos 25 squared, minus 4 times a, which is 1 times c, which is 33, all over 2a, which is just 2. And then if we pop these in, we should be expecting to get the two answers that we got using the sine rule method. Okay, so the first answer that we get out, 9.04 centimeters, and the second answer that we get out of that is 3.65. Okay, so much less working involved, but you do have to deal with this quadratic correctly. And also there may be an option, there may be a scenario where the question actually tells you, it says it might say using the sine rule solve this problem, so you might be forced to do it the other way. But you've seen both ways now, so you can make a decision for yourself which you prefer to do. Okay, question 6. So this time we have been given the area of a triangle. We've got a couple of sides and we've been told this information down here, the EFD is acute. Now as soon as you see anything to do with the area in a question like this, you can straight away write down your half AB sine C formula, and we're actually going to be working backwards in this question. Now remembering that the angle that goes into sine in the area formula is always the angle between the two sides that you have. So if we reverse this formula, it will be this angle here that we find. We've got an x in the question already, so let's call this angle y. So we are going to have half times 3.2 times 5.4 times sine of y equals 4.32. Okay, so if we divide the 4.32 by a half times 3.2 times 5.4, then we get 1/2. And those of you that know your exact values very well will instantly go, oh, I know what y is, because a half is one of those exact values. And that in fact is 30 degrees, so well done if you knew that. Now, if you've noticed, there is also another answer to this. Okay, so in the ambiguous case that we've seen in the last two questions, sine has two answers, both an acute and an obtuse value every time you do inverse sine. So we could have 150 degrees as a possible answer here. However, we do not have to worry about that in this question, because we've been told that we're working with the acute angle for angle EFD. So we can be happy that we can just use the 30 degrees. But it is always worth thinking to yourself, okay, what about the other answer that I can get from sine? Make sure that you don't miss anything in the question. And now that we've got our 30 degrees, we can think about how we're going to move forward and find x. So two sides, two angles, it definitely seems like it's a sine rule problem. However, we've got the side opposite the angle that we're after, but we don't have the angle opposite the other side that we know, which means we haven't quite got enough information to make any two parts of the sine rule actually work. We also can't find this other angle, although we could write it as 180 minus 30 minus x and then solve that way. But I think what this question's expecting us to do is use the cosine rule to work out the side over here, so ED, so I'm going to call this, well, let's label our triangle with the usual ABC, then we would have an automatic label for it. Okay, so side C is what I'm talking about here. If we use these two sides and this angle to work out C, then we do have a side angle pair that we can use to work out the X in the question. So I reckon this would be maybe a 5 or 6 mark question because it's got a few steps to it. So next we're going to be wanting using the cosine rule. This is going to allow us to work out C squared. So 3.2 squared plus 5.4 squared minus 2 times 3.2 times 5.4 times cos 30. Okay, so we'll pop that in. And we get 3.0774. Again, I'm going for a few extra significant figures than what I would be looking to give my answer to, so that I can avoid any errors carried forward in those first 3 significant figures. Okay, now I know that this is 3.0774, then I do have enough information to use the sine rule. So now I can put sine x over 3.2 equals sine 30 over the side I just worked out. So what we're going to get there, sine x equals 0.5199, etc. And then if we do inverse sine on that, we get 31.3. And that's our final answer, so we can leave it as 3 significant figures. We can see from the question that it is acute. So we know we are done. Okay, final question. Now this is a question where we have 2 triangles put together. I feel like this is going to be a question that requires quite a bit of working. So let's see what we're working with here. Okay, so we've got a couple of sides, we've got a couple of angles, but one of them sits in a different triangle. So all of this information here is information that's already been drawn in the diagram. And it's telling us to find the area of triangle ABC. So that's the larger triangle. Now, finding the area of triangle, that's a half AB sine C. Now, if we look at what we've got, we do have an angle with 2 sides on each side, but unfortunately it's not going to be as simple as that because the 8.1 is only CD. It's not CB, so we're going to need to find out this side here in order to have the full side so that we can put it into that formula. Okay, so we need to kind of think backwards from where we want to be. If we want this side, we do have the angle opposite, but at the moment we have no other information about this smaller triangle up here. We are going to need possibly maybe this angle here combined with the side AD. That way we would have enough to use the sine rule. Otherwise we would need to find the side AB. I think there's going to be a couple of different ways of getting to this answer. So you may use a slightly different route to me, but our answer should match up at the end. So I'm going to come back to the triangle at the bottom. This is the triangle that we actually have more information for. I'm going to start by working out length AD because this is a side that is shared between the 2 triangles. So working it out for this triangle will tell us at least one of the sides for the other triangle. So AD, we need to call it something. Let's just start with x. So x squared is going to be 8.1 squared plus 15.4 squared minus 2 times 8.1 times 15.4 times cos of the angle between 32. Pop that in and see what we get. Okay, so we get 9.5498. Now, okay, this is where I'm going to use a slightly different method for making sure we don't get any errors carried forward. Rather than writing down some, well, I will write down some extra decimal places here, but I'm not going to type this number in again. I'm actually going to save it on my calculator so that I can just plug in this value, well, not exactly, but to however much the calculator's recorded it to really reduce the chance of carry through errors. Now, I've got a little bit of the calculator down here just so I can show you what you need to be doing in order to store. So let's say you've just worked this out, you've got this on the screen of your calculator. You are going to press the store button here, and then you choose, so you see these little red letters, A, B, C, D, etc. So I'm going to press this button for A, and what you should see on your calculator is it should say answer, arrow, capital A. If you now clear what's on your screen and press alpha, and then the button that has the A next to it, you'll have a capital A come up. You press equals, you should get that number back. So I'm going to make a note on my working here that I've stored this as A on my calculator. Now I can just put that straight back in as A in all of my working. Okay, so what do we need to work out next? Well, it would help to work out this angle at the top. Now, looking at my large triangle, I already have the angle of 32 down here. If I could work out this angle here, and I could add it onto the 24, then I could take these two angles from 180 and I would know my angle at the top. I would then have enough information to use the sine rule to work out this little BD, and then I could use my half AB sine C formula. So we're going to come back down to this triangle at the bottom, and we're going to look and go, okay, well, we've got a side and an angle opposite, a side and the angle we want opposite, so I'm going to call this a y, so we can use the sine rule. So sine y over the opposite side equals sine 32 over its opposite side, which is A. And this is where my storing it in my calculator comes in. So this means that I have sine y equals 0.449, etc. You inverse sine on that, and I get 26.709. So here's another value that I need to store. So again, store button. I'm going to press this one here this time to store it as B. I'm going to make a note in my working that I have stored this as B. And now I can again just sub in B into any formula where I need to use that value. So now we're coming back to this triangle because, okay, we need to find angle B. So actually this I should say ABC. So this is going to be the 180 minus 32 minus the 24 and minus the angle we just worked out. Let's see what that is. Okay, so here we get 97.29. Oh, just a note, by the way, if you were thinking, hold on, why didn't you mention the ambiguous case with sine? What about the fact that there's a obtuse answer to sine y equals 0.449? Well, there is, yes, but it's very clear from the diagram that y is in fact acute, so I knew that we were fine using the 26.709. Right, now this answer here, I'm going to store this one, seeing as it's so easy to do. I'm going to put this one in as C. There we go. And now I think we are ready to do our final calculation, well, second to last calculation, sorry, this is quite a long question, this one. So we can come back up here, so we know this one. I'm going to pop in our value. So this is about 97.3. X here is about, where was it, 9.5. And we're now going to put this into the sine rule because we've got angle and side opposite, angle and side opposite. This is what we want to know up here. I'm going to call this little a, seeing as it's sitting opposite angle A in this triangle. So sine, oh no, started the wrong way around. We want our sides on top because we're trying to find a side. So a over sine 24 equals our red A, which is the one we stored up here. So this is our x, the 9.5498 over sine of C, this angle here. So I put it in red to make sure that we're not getting confused with the angles in the diagram, these labels here, that we remember these are actually the things from our calculators. And if we work this out, we get 3.9 2. Well, 3.915, etc. Oh, there's a bit of a gap there. Okay, so now we're ready for our final part. We're almost at the end of the question, finally. So area is a half times 15.4 times our length, this longer length here, BC, of 8.1 plus our 3.915. Now this number's still on my calculator, so I'm going to leave it there and sub it into this in my working. I could store it, but seeing as I'm not going to do any other calculations other than this final one now, I'm just going to keep it as the answer button. So answer in my calculator. And then don't forget we need to times by sine of 32 on the end as well. Let's see what we get. We get 49.0 as it turns out, because it's 0.0294, so I can just stop there, or put 49.0 to be safe. Centimeters squared, because it's area. My answer is do 3 significant figures. And there we go. So that was quite a long question, lots of multiple steps. We use the cosine rule here to work out a side. We use the sine rule, sorry. Angles in a triangle add up to 180, another go at the sine rule, and then finally the area formula. So these can be some of the harder questions on the GCSE paper, one of the last few, especially if they've got this many steps involved. There's quite a few things to think about, but once you've done enough practice, you'll know your formulas fairly well, so you won't have to worry about those. Hopefully you'll have experienced the ambiguous case of the sine rule enough to be aware of it. And the rest of it's really just being very careful if you're working and not making any silly mistakes. We've also seen here this storing numbers on your calculator. I will use this in my videos where I think it's appropriate. Here it most definitely was, because there were so many different values that we would have carried forward. If we'd rounded these early on each time and just carried those numbers forwards as their rounded versions, then it's likely our answer would have come out maybe 0.1 or some amount different to what it should have been, and we would have lost that final accuracy mark. So it's definitely worth learning how to save numbers onto your calculators using that store button and then the alpha button to bring back any of the letters for which you have a stored value. Okay, well, thank you for watching, guys. If you enjoyed the video or you found it helpful, then please don't forget to hit the thumbs up button and subscribe if you'd like to see more. There are a lot more videos coming on the GCSE and the A-level. I look forward to seeing you in the next one. Bye.